This video is sponsored by PCBWAY, and this is another milestone now in the Pesky Padauk Programmer project. I'm going to move from the original version, which is predominantly SMD. There's the crystal, which is through hole, but everything else, and a couple of the connectors, everything else is pretty much SMD, and therefore, has been quite problematic for me, at least anyway, to solder that up. And out of 5 attempts, I've got one which sort of works, in that it programs the PFS 154, but doesn't program the PMS 150C, which is the one-time programming version. So I made an old man version, and PCBWAY were very overconfident in my abilities, and they have come along for the ride here, and they have not only manufactured but also sent this along. So very generous of PCBWAY to do that. I'll put a couple of links at some point in this video so you can go and have a look at their site themselves. It's very, very straightforward to, if I can do it, anyone can do it. So you can easily design your own PCBs and have them manufactured by PCBWAY. This one here, you'll see some similarities. When we go through it, it's still based on the STM32 chip, which you can see here, and we can see the space for here. It's still got the crystal and a couple of other SMD components, which I haven't swapped out. Almost everything else is through hole. So I'm going to switch to time lapse. I'm not sure how long this will take, but I'll unpackage this, and another thing which I'll show you is the actual. What I've done is I've put together a container of all the bits and pieces. So it looks a little like this, and it's just got everything labelled so that whether I'm making the SMD version or I'm making the through-hole version, I've got all the bits and pieces handy. So for instance, if I'm looking for something like a 20K resistor, then I've got in there, you can see the SMD 20 kilo ohm, and you can also see the through hole. So I can just pull out depending on what I want. And from the last video, which was the one about the mailbag, this is the actual STM chips ready to go. So yeah, hopefully it'll go pretty smoothly, and even more hopefully it'll work on the other side of it. Let's switch into time-lapse mode and get this done. Okay, so first order of business is to put on the STM32 chip, and I've actually poorly adjusted the camera here, so with it being directly overhead, there's a fair bit of hair involved in this construction, but the second time lapse that I do, I actually put it at a slightly different angle, so I only have to put up this for a few more seconds. And that looks like it. Okay, so the STM32 chip is in place, and now we're looking at the op amp, and there's the couple of transistors. So these are the little SMD parts now that I'm putting on all at once. And you can see there's not too much different from the old man version, which I'm working on, compared to the SMD version for those components. The one that's probably been the most difficult is this little USB connector, and looks like I've got one little SMD part to put on there. But I'm actually getting more and more confident with that USB connector now, and in fact for this whole construction, there was really not too much in the way of problems there. Just got to take it a little slow and check as you go. And in the end, it wasn't such a big issue. So that's nice. And that's getting close to all the SMD parts done. So that's probably the scariest thing out of the way. So now I've got 12 100 nanofarad capacitors to put in here, and what I did, which is different to the original, so on the original it's got things marked like C4 and C17 and things like that, which I struggled a little bit with. So what you'll see on my version is that the actual capacitors are all named. So that this is a 100 nanofarad here, and instantly we can see a problem. Look at that. So I'm going to have to squeeze these in. They're going to look pretty comical sitting up there. But so what I might do is I might pre-bend these guys in and then out again to fit into that form factor. So that was obviously, again, another little error on my behalf. So let me come back when I've squeezed all of those in to get to be a more normal size. So they're all bent now. Has that changed the characteristics? I wouldn't expect so, but it's the sort of project where if something can go wrong, it will. So let's try this one. Should be close to 100 NF, and it's 100.2. So, all right, good. So now let's start shoving these in. And they are all over the place. There's 100. So you can see I don't have to look up anymore, what C17 is or whatever. I just need to spot the ones that say 100 NF and pop these little guys in. So yeah, they're comically oversized. In fact, these are so close together, I'm going to have to put them at a slight angle to get them in. Oh, that's not too bad. Let's go for the next one. And now I've made them a little too close together. No, it's not too bad actually. All right, we'll keep going. So there's 12 of them. There we go. Now I'll start soldering them in. So they're going to look like soldiers standing around guarding that processor, which I suppose in a way they are. Nobody likes transients. And if you think this is fiddly, you should try the 0603 version, which I've effectively abandoned even on the old one, shoving in 0805s. So we've got 3 to go. Where are they? Oh, there's one up here. And one here. And one next door. And there's my 100s. That's a satisfying click as it goes in. So, and falls out. Oh, that's funny. They look like they were holding. Now, where did these guys come from? Okay, there's one there. All right, so he's a bit loose. Let's curl him over a little bit. There we go. In fact, I might squeeze all of them over a little bit. That's good. Where did this guy come from? Aha. All right, I might go back to time lapse for soldering, because that's not as exciting as having capacitors falling out upside down. And there goes another one. Let's get these guys in and we'll fix that reluctant one. Alright, good. Oh, that was fun. You can still see there's actually one on the mat. But they all get squared away eventually. I did say earlier that I would show you the PCBWAY website and how to do all that. Look, there's some great videos out there of doing that. So I might do that actually as a separate video at some stage, but I'll just put the links below and in the blog so that you can go to PCBWAY. It's dead simple. Just use your normal CAD program whatever you use to actually design the circuit, export your Gerber files. I found actually PCBWAY to be amazing when it comes to spotting problems, whereas some other manufacturers are just happy to take your Gerber files and give you back rubbish. PCBWAY will actually contact you and go, yeah, maybe you want to rethink that, and that's been very good. So yeah, links below and on the blog, and I highly recommend it. Now there's a little bit of desoldering going on there, because one of the capacitors I actually put across the two holes of the diodes, so that was pretty comical, and I couldn't find out where to put that. I also made quite an error. The ones that I'm putting in now are supposed to be 100 ohm resistors, and then I come to a certain section. There's the LEDs going on. Come to a certain section, and I'm thinking, wait a minute. There's some more 100 ohm ones to go in. It didn't sort of make any sense to me, and it turns out that I'd flipped around the 100 ohm and the 100k. So yeah, rookie mistake. So what I end up having to do is to pull all those 100 ohm resistors out, and you can see there I'm actually going to cross out on the label there, and there I am testing. I'm going, oh, yep, got all those wrong. So clipping all those off, and then using the old solder sucker to get rid of them all. Very tedious. Probably added an extra, I don't know, 5 or 10 minutes actually. Firstly, trying to figure out what was going on, and secondly to rectify it. So this project, it just keeps giving. Anyway, that is about it. I've just got some pictures here of various, so that's just with all the SMDs on. These are various stages of the project. And then we've got the SMD components and the 100 nanofarad capacitors in. So, and then we've got the diodes I can see in, the 47 microfarad capacitors in there, some resistors, there the crystals in, there's the phone going in the background, and this is now just getting some close-ups of the chip just to check to see if there's any bridges, and just having a look at the soldering on those pads, and a couple of the other SMD components. That's the MT3608 and the little transistors, so tiny. That's the op amp, and I think now what we've got is that is it in its entirety. So the next thing to do is to actually take that board and to plug it in and to load the firmware up. So I know that we've done this before on a SMD version, but this is the old man version. So here we are, and classic, no DFU capable device available. And of course I'm going here through VirtualBox, so what I've got to do is actually unplug it, plug it back in, and then tell VirtualBox that I've got the USB device in there. And I think while I was doing this, I actually forgot also to press the button. So in order to load up the firmware, you've got to press the button on the board, plug it in, then tell VirtualBox that it's there. Of course, if you're running a normal operating system, then that's fine. But yeah, if I can make a mistake, then I will. So hopefully now, and look at that. Now that is a beautiful thing. So at least this board works to the point where we can upload the firmware. And the next stage is to plug a chip in and see if we can program it. But at this stage, I'm pretty happy with the result. A few little hiccups along the way, and undoubtedly still a few ahead, but yay, success, which as it turns out isn't a Linux command, but I was pretty stoked at this stage. So that's the circuit working today. We'll come back and we'll try and actually program a chip with it. So see you next time.